So there are two cases. These two cases also you have to understand. Case 1. Case 1 says that no banking. No banking means no angle, understood. No banking of the road, but friction is present. Friction is present. In that case, what will be the safe speed? If the the road is horizontal, but the car is taking a turn, understood. The road is horizontal, understood. There is no angle here. There is no angle here. The road is horizontal road. Understood. The road is horizontal and the car is taking a turn. There is a sufficient friction. There is a sufficient friction. The car is taking a turn like this. That the car will not skid away from the track. The car has a tendency to move away from the track, but there is a sufficient friction which prevent it, which prevent the sliding. So that is what I am explaining. No angle is set, but friction is there. Is it okay? Till this step you understood? Till this step? All of you clear? Understood? Please respond. No banking means no angle. The road is horizontal. Okay? Friction is there. So, what is the general formula? This is the general formula. Let me write here. Never forget this formula. The maximum or safe speed is given by the general formula Rg into, you have to memorize this, mu s plus tan theta. I have derived this formula by 1 minus mu s tan theta. This formula we studied in the previous class. If no banking but friction is sufficient, so if theta is not there, the theta will be 0, then tan theta will be 0. You studied in 10th standard that tan 0, 0. Actually it is there in 10th standard. If you don't know, better memorize right now. If there is no banking, theta will be 0. Tan 0 will be 0. Tan 0 will be 0. So the formula becomes, I will write in the right side. Okay, I will write all the steps here. So in this case, theta equal to 0. Understood? Theta equal to 0. I am going to substitute in that formula. Vmax is equal to root of Rg into mu s is there. The friction is there. Theta is 0, so we get tan 0 divided by 1 minus mu s tan 0. So what happens is, tan 0 will be 0. This entire term cancels. Tan 0, 0. Let me complete it. After that, you can ask me a doubt. There are problems based on the cases. There are two cases. So Vmax is equal to root of Rg into this tan theta. This term cancels. This term also cancels. Only mu s by 1 is remaining. Mu s plus, okay, I will show that step so that you should not have any doubt. Mu s plus 0 divided by 1 minus 0. Tan 0 is 0, that is the reason. So memorize this formula. Maximum speed of the car for the safe turning will be root of, mu s is the root of mu Rg. Mu means coefficient of static friction. Okay, mu Rg. Memorize like that, mu Rg. So if there is no angle set or the horizontal turn, car has to take a safe turning. The maximum speed of the car should be root of mu Rg. Mu is the coefficient of static friction. R is the radius of curvature, meaning that there is understood. The radius of curvature will be there. Form a circle having some radius. And G 9.8. So all of you please write down this case 1. If you have any doubt in this case 1, you please ask me right now. Aryan ഇപ്പോൾ join ചെയ്തോളൂ അല്ലേ ആര്യൻ? ആര്യൻ ഞാൻ കണ്ടില്ല. ഈ പറഞ്ഞതിൽ ഏതെങ്കിലും ഭാഗം മനസ്സിലായില്ലെങ്കിൽ ചോദിച്ചോ ആര്യൻ. If you have finished and no doubt, then raise your hand. Deva, Rakshana, understood. All of you clear? Deva, Rakshana, Aaron, understood. Aryan doubt undi chodikka. Case 2. Case 2 chodikku exam. This will be asked in the exam. Okay. Case 2 means banking is there. Banking is there. Means theta is there. Understood? Theta. Theta is present. But no friction. Suppose during the rainy season. Understood? During the rainy season, the car is taking a sharp turn. If it is raining heavily, the friction is too small. Understood? The friction will be too small. Think like that. Understood? Naturally, there will be some friction. But suppose think like that. There is a sufficient rain. Due to the rain, the friction is too small. Think like that. No friction at all. But angle is set. So the road look like this. Understood? The road look like this. This road making an angle theta with the ground. Horizontal. The car is taking a turn. Understood? Taking a turn. Taking a sharp turn. So in this case, the general formula, let me write the general formula. Vmax equal to root of Rg into mu s plus tan theta divided by 1 minus mu s tan theta. If no friction, that mu s will be 0. The friction, if mu s is present, there is friction. Understood? If there is no friction, mu s will be 0. This entire term 0. So Vmax equal to root of Rg into 0 plus tan theta. Theta is set, but the friction is too small because of the heavy rain. Think like that. Divide by 1 minus 0. Mu s is 0. Friction is too small. So the maximum speed of the car should be root of tan theta is remaining here. It's very simple. Tan theta by 1. Root of Rg tan theta. You must memorize this. These formulas are required in problems. The two cases you have to understand. The general formula you have to memorize. Also, both the cases also you have to memorize. No angle. Then maximum speed of the car is root of mu Rg. If the friction is not there but angle is there, then maximum speed of the car will be root of Rg tan theta. So all of you please write down all this formula. If you are okay, 100% clear and written everything, then raise your hand.
Diagram, sir.
Any doubt? Please ask.
Sir, the diagram in case 2, sir. Can you explain?
That diagram, okay. It's very difficult to draw a beautiful diagram. Very difficult to draw. Look at this diagram. Can you see a car? Okay. Can you see a car is taking a turn? Is it okay? A car is taking a turn. At the, if there is a turn, the angle is set. This is the road. Understood? This inclined plane is the road. This inclined plane is the road, making an angle theta with the horizontal. Because of the rainy season, you please think like that. Because of the heavy rain, the friction is too small. Friction is too small, but angle is there. So in this case, the car is taking a turn. Car is taking a turn. Understood? So in this case, the maximum speed. Friction is not there, but angle is there. So in this case, the maximum speed of the car is. That formula is written. Okay? Clear?
Yes, sir.
Okay, Deva understood. Rakshana, Aaron, Aryan, ഏതെങ്കിലും ഭാഗം repeat ചെയ്യണോ Aryan? Clear ആയി? All of you please write down. Please raise your hand if you have written. Okay, all of you have understood. Let me discuss some question from textbook. It's taken from textbook. It is example, but these examples, these are good questions. Let me discuss this. A cyclist speeding at 18 km per hour on a level road. Level road means theta 0, understood. There is no banking provided. It is a road like this. There is no theta. Level ground, level road, understood. Cyclist, let me draw like this, taking a turn, understood. The speed of the speed is given as, let me denote by speed is denoted by v. The speed is given as 18 km per hour. The speed of the cyclist is 18 km per hour. Is that okay? All of you clear? Please respond. Is that okay? So the speed of the cyclist 18 km per hour, but our standard unit is meter per second. I explained in the previous classes, don't forget it. This is 18 into kilometer per hour can be converted to meter per second by multiplying with the 5 by 18. Okay. Kilometer per hour can be converted to meter per second by multiplying with the 5 by 18. I discussed before. Okay. Please don't forget it. So the speed of the cycle is given as is equal to 5 meter per second. This is the speed of the cycle. Question is it the safe speed? Will the cycle skid? Skid means will it drift slowly towards the outer boundary of the road? Okay. So is that question? Is it the safe speed? That is a question. Will the cyclist slip while taking the turn? So the radius is given, understood. If they are taking a turn, it will form a circle having a radius. Radius is 3 meter, understood. The radius of curvature is 3 meter. Let me complete this problem. After that you can ask me doubts. The coefficient of static friction between tire and the road, which is mu s, understood. The coefficient of static friction. You can ask me doubt after completing the solution. Coefficient of static friction is given in the question, 0.1. Given. Will the cyclist slip? That is a question. Yes or no? Okay, that is our question. So let us find out the maximum speed. Maximum speed. We have a formula. There is no banking. Friction is there. So which formula? Case 1. Understood. Consider the case 1. You must memorize the formula, okay? Otherwise you have to derive it. So no banking, flat road, but the friction is there. Maximum speed is root of mu rg. Root of mu rg. Maximum speed of the cycle is root of mu rg. Root of mu is 0.1. R is the radius given 3. G we can approximate it as 10. Okay. 0.1 into 10 becomes 1. Root 3. Do you know the approximate value of root 3? Anybody? Do you know the approximate value of root 3?
1.7.
Yes. 1.73. 1.73 meter per second. This is the maximum speed. But the cyclist is moving at what speed? The cyclist is moving with the 5 meter per second. It is above the maximum speed. Understood? The given speed, the speed of the cycle is much greater than the maximum or safe speed. 5 meter per second is much larger than 1.73. So definitely the cyclist will slip. Understood? Clear? The cycle will definitely slip. The speed of the cycle should not exceed the maximum speed. The maximum speed is 1.73, but his speed exceed that limit, 5 meter per second. So the cycle will slip when he take the turn. All of it clear? The question is okay?
Yes, sir.
So please write down. Deva, Aryan, please ask your doubt. If you are 100% clear, raise your hand. Deva, Aaron understood. Rakshana understood. Aryan, എന്തെങ്കിലും റിപ്പീറ്റ് ചെയ്യണോ? ആര്യൻ ഇത്രയും പറഞ്ഞതിൽ
വേണ്ട സർ.
ക്ലിയർ ആയി? ഓക്കെ. So the important question I discussed. 1 minute. Let me discuss. Just a minute. 1 minute. Just please wait. I need one more question. This question I am going to discuss, taken from textbook. Okay, I will read this question. All of you please listen. If tan theta is required, it will be mentioned in the question, because the calculator is not allowed for CBSE. So definitely, if tan theta is required in the question, definitely it will be given. I mean, use tan 15 equal to point something. It will be given in the question. Okay, so let me read the question. A circular racetrack of radius 300 meter is banked at an angle 15 degree. If the coefficient of friction between the wheel and a race car of the road 0.2, what is the maximum speed of the race car to avoid the wear and tear of the tire? Maximum permissible speed to avoid slipping. 1 minute. I will explain the optimum speed. Actually, it is not properly mentioned in the theory part. I will explain that. Okay. So all of you please listen. There is a circular track of radius. 1 minute. There is a circular track of radius. Let me take this diagram. 1 minute. Just a minute. All of you please listen. So the car is going to take a turn. Understood? Car is going to take a turn. A circular race track of radius. The radius means, please memorize, the car form an arc. If I complete that arc, I will get a circle like this. Understood? That is said to be the radius. Understood? Please note that. That is radius. 300 meter. Radius of curvature. It is said to be the radius of curvature, 300 meter. So a circular racetrack of radius 300 meter, understood, is banked at an angle 15 degree. This angle is 15 degree. If the coefficient of friction, which is μs, coefficient of friction is 0.2. Understood. Let me connect the charger. 1 minute. And anything given, what is the optimum speed? I will tell you. So the diagram is clear to you. Please respond. The diagram is clear. Please respond.
Yes, sir.
Okay. Optimum speed, the optimum speed means it is also maximum speed. I will give you a simple definition for that. Optimum speed means, let me write it in sentence. Optimum speed means maximum speed. Maximum space safe speed if no friction, if friction is not considered. Is not considered. Yes, it is, maybe it is possible sometimes. Understood. I told you that if there is a lot of oil, understood, there is a lot of oil on this road, the friction is too small. Or suppose there is a heavy rain. There is a heavy rain. In that case also we will neglect the friction. So optimum speed means we have to, that one should, we have to consider. Understood. Sometimes there may be friction, sometimes there may not be sufficient friction. So optimum speed means we are considering, we are assuming that there is no sufficient friction. Understood. So in this case, optimum speed. Optimum. So please think like that. The optimum speed means the friction is not considered. So the mu s, we assume that it is 0. Is it okay? All of it clear? Please respond.
Yes, sir.
So the case 2, do you remember the formula? Case 2, if the friction is not sufficient. If the friction is not sufficient, I have written that. Okay, what is the formula? Tell me. Root of Rg tan theta. Is it correct? Please.
Yes, sir.
Root of Rg tan theta, if we are neglecting the friction. That is said to be optimum speed. You can think like that. So root of tan 15 degree will be given in the question. Okay, they will definitely give the value of tan 15. Otherwise we have to use the calculator. It will be given in the problem. Don't worry about that. Okay, root also I think it will be given. R radius is 300. Let me complete this question. After that you can ask me doubt. Tan 15 degree will be there. Let me complete this optimum speed. After that you can ask me doubt. Okay, tan 15, 1 minute, let me check it. Tan 15 degree, tan 15, 0.26, 0.27, it will be given in the question. Okay, it will be given in the question. Let me complete. After that you can ask me doubts. So what is the product? 27 into 3, 81. Or you may do one thing for the simplification. 3000 into 0.27 is 27 by 100. Understood. Is it correct? Yes, 0.27 is 27 by 100. But I think you will not be getting a good answer. But 0, 0 cancelled. 27 into 3, 81. 1 0 is pending. That is written separately. 27 into 3 is 81. But 1 0 is there. It is corresponding to 10. 81, root 81 will be 9. You know that. Root 81 is 9. And root 10, if the calculator is, yes, calculator is not there, so root 10 will be given. Okay, let me add in the question. Okay, 1 minute. Root 10, 3.2. Okay, so 3.2. Root 10 is there. Root 81 9, root 10 is 3.2. 9 into 3.2. 28.8. 28.8 meter per second. This is the optimum speed. We assume that the friction is not sufficient. Okay, so you please write down this part. If you don't understand, you please ask. Okay, the first part is done. Deva, Rakshana. One minute. I'm just coming. All of you clear? Please respond. All of you clear? Hello? Understood?
Yes, sir.
Okay. The second part, Vmax. If they simply say that maximum speed, the friction also we will consider. Understood? Maximum permissible speed to avoid slipping. So that in that case we will consider the friction. But for optimum, we will not consider friction. So Vmax equal to root of, what is the formula? Do you remember that? Rg into mu s plus tan theta divided by 1 minus mu s tan theta. Lot of calculations is there. For the time being, I don't want to discuss the calculation. R is 300, G is 10, mu s is what? 0.2. Tan 15 degrees 0.27. 1 minus 0.2 into 0.27. You can do the calculation later, okay? For the time being, I don't want to discuss the calculation. It is there in textbook. 1 minute. Let me avoid the calculation. 38.1. 38.1, yes. For the time being, it is already solved in the textbook. You may do the calculation after the class, okay? 38.1 meter per second. Let me leave it. Avoid calculation. You can do after the class. So, optimum speed is 28.8. Maximum speed, if they simply say maximum speed to avoid slipping, you have to consider the friction also. So all of you please write down and ask me if you have any doubt. Deva, Aaron, Rakshana, Irene.
Yes.
Completed. All of you have finished?
Yes, sir.
Okay, okay. The chapter is over. Let me discuss a few indirect problems from this chapter. Today I am not planning to start a new chapter. Let me discuss a few problems outside textbook, okay? So friction is over. Then there is another, let us look at this question. Not there in textbook. Let me read it. Indirect question. A body of mass 10 kg is moving with an initial speed of 20 meter per second. The body stops after 5 seconds due to friction between body and floor. The value of coefficient of friction is. Actually, it is a JEE problem, okay? But you can do it. It is not hard. We can do the problem. All of you please listen. Let us draw a rough picture. Let us draw a rough picture. The body is moving on a floor, along a floor. Let me draw a floor like this. There is a body of mass 10 kg. If you draw the figure, you will get confidence. Otherwise, you will read this question. You will not write one single step. If you draw the diagram, you are able to start the problem. The mass is 10 kg. Initial speed is given. Initial speed is normally denoted by u. Understood? The initial speed is 20 meter per second. But this body is moving with the initial speed this much. But there is a friction. Due to the friction, after moving certain distance, the body stops. Understood? Clearly mentioned the question. After traveling certain distance, the body's final velocity becomes 0. Means that it is stopped. Understood? You know that if the friction is there, the body will stop after moving some distance. Till this step you are okay? Till this step you are okay? Please respond.
Yes, sir.
Okay. So stop 5 seconds time. Yes, yes. The motion time is 5 seconds. 5 second time. The body take 5 seconds to stop. The value of the coefficient of friction. If the body moving forward, the friction will oppose it. It is said to be kinetic friction. The body is actually moving. The kinetic friction is there, which opposes the motion. We have already studied, which is very similar to somebody is pulling backward. Somebody pulling it backward. As a result, the speed reduces. If somebody pull it backward, its speed will be reduced gradually and finally becomes stopped. So the Fk, I don't know, the coefficient of kinetic friction is there. But we have a formula. What is that? Do you remember? Kinetic friction has a formula. Anybody, please tell me. What is kinetic friction formula? Don't remember? You forgot it. Mu k into n. In the previous class we studied. Okay?
Shall I say?
Yes, tell me. Any doubt? Hello? Any doubt? Do you have any doubt? No. So we have studied it as a law of friction. Understood? I have written it. Law of kinetic friction says that the kinetic friction is equal to mu k into n. N is the normal reaction. The ground apply an upward force on the body. That is normal reaction. The ground apply a normal force on the body, normal reaction, for a horizontal surface. You have to revise the previous classes, okay? For the horizontal ground, in a normal reaction is same as mg. Normal reaction will be equal to, numerically equal to weight of the body. mg. Understood? So mu k into mg. Mu k we don't know. Let me write mu, okay? Mu k means, let me denote by mu. Mass of the body is 10. G is also 10. So the kinetic friction, backward force, is equal to 100 mu. But mu is our question. Till this step you are okay? Aaron, Aryan, Rakshana, Deva. Till this step you are okay?
Yes, sir.
Okay. So, since there is a backward force, the body experiences retardation, acceleration, negative acceleration. See, if there is force, there will be acceleration. Acceleration of a body means the net force experienced by the body. I have already explained that. What is a deceleration? Let me say deceleration. Velocity is decreasing. The deceleration of a body or acceleration of a body is given by net force acting on the body. Net force acting on the body is minus 100 mu. Frictional force. Why it is negative sign is given? Because the force is a vector quantity. If the force towards left, it is written as negative. But if the force towards right, it is written as positive. Force towards left, it is written as minus. So in the previous classes I told you that the acceleration or deceleration of a body equal to the net force on the body divided by mass. I have already discussed that formula. Acceleration or deceleration of a body is equal to net force. So the body is supposed to move in the horizontally. So the net horizontal force, understood. The body is moving horizontally. So the net horizontal force experienced by the body is Fk only. Fk divided by mass. Mass is 10. So acceleration is equal to minus 10 mu. Not completed? You please read all these steps. Till this step, you please read all. And if you don't understand any step, you please tell me. If you are 100% clear, then only you have to raise your hand. Okay. Rakshana, okay, understood. Deva, Aryan, clear. Aaron, understood. A equal to minus 10 mu. So A equal to acceleration of the body, I mean deceleration, is equal to minus 10 mu. What is our question? Mu is our question. U is there, V is there, A is there, T is there. Any formula connecting these highlighted terms? U, V, A, T. Is there any formula connecting all these letters? Anybody? U, V, A, T. Don't remember? V equal to U plus A, T. Understood? Actually, it is there in the second chapter, but you studied in the lower classes, 9th standard. Is it okay? Devasri, Rakshana, Aryan. V equal to U plus A, T.
Yes, sir.
Remember this formula. V equal to U plus A, T. V is the final velocity 0. U is the initial velocity, which is 20. Acceleration is minus 10 mu. Look here, acceleration is minus 10 mu. Time is 5 seconds. So 0 equal to 20 minus 50 mu. Mu is our question. Coefficient of kinetic friction. Arranging, you just do the arrangement. 50 mu equal to 20 or mu equal to 20 by 50. 0 cancels. 2 by 5 will be 0.4. Kinetic friction is 0.4. It's an important problem. Please go through all the steps and you can ask me doubts. Okay. Please raise your hand if you are 100% okay. Understood? Rakshana, Deva, Aryan, Aaron, all of you clear?
Yes, sir.
Okay.
Yes, sir.
Understood. The friction not there. So today I'm not planning to start a new chapter. So today's class is clear? All of you okay? Today's class is clear?
Yes, sir.
So there is no problem related to friction. This is not friction question. There is no, so let me wind up the today's class. In the next class I will start a new chapter. That is better. So Deva, you need the second chapter, right? Motion in a line. Aaron, ഇപ്പോൾ ഏതാണ് currently എടുത്തുകൊണ്ടിരിക്കുന്നത്? Aaron?
Sir, motion in a straight line.
അതന്നെയാണ്.
Work, energy, പിന്നെ power.
Okay. Let me plan, Deva, okay? Deva, Rakshana. So let me wind up the class today, okay? Okay, bye.
Thank you, sir. Bye, sir.
Sir, I have exam on June 2nd, sir, for physics.
Which chapter?
So the first two chapters, units and measurement and motion in the straight line.
You please message the chapter list for the exam, okay? Otherwise I will forget it. You please send me WhatsApp message, okay? Then I will prepare a separate schedule, okay?
Yes, sir.
Okay. Then.
Thank you, sir.
Okay.